Okay, so picking up where we left off for 5.3, we flipped everything around to get our inverse. The only other important piece of information that we need to talk about is when we have the cosecant of the arc cosecant of x, what happens there. And it should equal x because they're inverses, but this is only true if x is an element between negative infinity and negative 1, or from 1 to infinity. So this is because arc cosecant itself only exists between there and there. It does not exist between those two. Okay. And you can kind of think of these as like sort of asymptotes. They're not exactly. They're really just the edges of the range. But it's there. Okay. So it only exists if it's between negative infinity and negative 1, or from 1 up to infinity. It's the only place it exists. So if it doesn't exist, you can't plug it into cosecant. Okay. And then conversely, the arc cosecant of the cosecant of x equals x, but only if x is between negative pi halves and 0, or between 0 and pi halves. So essentially it has to be between negative pi halves and positive pi halves, but it can't equal 0. And it can't equal 0 because it was an asymptote here, which means it's an asymptote here. It cannot equal 0. And same thing, if cosecant itself doesn't exist, there's nothing to plug in here. So unless cosecant is between here, there's nothing to plug in. So hopefully that makes sense to you guys. Let me know if you have any questions on that or why that happens. Okay, so moving on to secant, it's really, really similar. So we're going to take a look here first. So again, we have to make sure we're restricting our domain so that it's 1 to 1. So we restrict this one from 0 up until pi. Okay, so this is our restricted domain. It's from 0 to pi. And it does include both 0 and pi, but it should not include this lovely asymptote here. So we actually need to take that out. So it'd be from 0 to pi halves. Can't include that one because it's an asymptote. And then again from pi halves all the way up to pi. And our range is negative infinity to negative 1. And then again from 1 to infinity. It's actually the same as cosecants. And it's because it's never between these two, right? Never ever goes between those two. So then the domain, we would flip it around. It would be negative infinity to negative 1 and 1 to infinity. And then the range would be from 0 to pi halves. And from pi halves up until pi. The symmetry on this one is neither even or odd. Okay, so let's go ahead and put this graph together now. So again, we're going to be from 0 to pi. Oops, I missed a little bit on that one. That one up there. And then we also have an asymptote at pi halves, so somewhere in here we have an asymptote. Okay, and we can look at some specific points to help us figure out how this one looks. This one is at 0, 1. This one is at pi negative 1. So think about it this way. As we're going this way, we are going from here, and then we're getting bigger. We're approaching infinity with our y, which means our x, so we're at 1, 0, and our x should be getting bigger now because y was getting bigger. We flip it because it's the inverse, so now it looks like this. And then negative 1 being up at pi is right here. And then again, so from here it was headed, let's say up towards that point with y. Y was getting bigger, so then x should be getting bigger up until that point, which would look like this. Okay. And remember, these are not asymptotes. Okay, they are the end of your range, but they are not a true asymptote. Okay, they can equal that. It's just that it's not going to go anywhere past that. Okay, so again, we need to talk about the secant of the arc secant of x, and that will equal x because it's an inverse if this exists. So this will be true if we're between negative infinity and negative 1, or from 1 to infinity. If arc secant exists, then it works. And then same here, the arc secant of the secant of x would equal x only if it exists. So secant, the inside has to exist. So this would be if x is between 0 and pi, not including pi halves. And there you have it. Okay, so then how do we actually use these? How do we actually do them? So again, this is important that you think about what this is actually telling you. What this is telling you is that the secant of some angle theta is equal to 2. So what's your angle? That's what it's asking you. Well, this would also mean that the 1 over the cosine of theta would be 2, which would also mean that it's asking you about where the cosine of theta equals 1/2. Okay, and then you can check your unit circle and you can find where that works. And the answer is when theta equals pi thirds. Same thing here. This is asking you what is theta when the cosecant of theta equals the negative square root of 2? Well, then that would imply that it's 1 over the sine of theta equals negative square roots of 2, which would imply that the sine of theta would equal negative 1 over the square root of 2. Which then you can do that. You can rationalize the denominator, which will probably help you. This is asking you when the sine of theta equals the negative square root of 2 over 2. So that would be when theta equals negative pi fourths. Okay, and again, that's just from the unit circle. So then inverse cosecant, again, same thing. So you just need to walk through these steps. So I'll go ahead and put the answers up, but you should know how to walk through that logic to get the correct answer. I do want to make sure we also talk about one of these really quick. Let's actually talk about D. So this one is saying the sine of, or sorry, the secant of what angle would equal 2 root 3 over 3, which would be 1 over the cosine equaling that, which means that the cosine would actually be 3 over 2 root 3. And then we would have to rationalize again. That's why I wanted to go over this one. It's kind of a weird thing. So this ends up being cosine of theta equals 3 square roots of 3 over 2 times by 3, which ends up as 3 root 3 over 6, which actually ends up with root 3 over 2, which is really strange. You could also think about doing that, unrationalizing it here before you go through this whole process. So you could think, oh, well, that's really 2 over the square root of 3. And then you can just flip it upside down. So that's fine either way. You just need to know that it needs to be unrationalized at some point. So then where is the cosine of theta equal to root 3 over 2? And the answer to that one is pi 6. Okay, and then finding the exact values. So what you're checking is, okay, arcsecant has to exist in order for this to happen. And remember that really this is an angle that's coming out of this, okay? But you need to check, are you between negative infinity and negative 1? Or between 1 and infinity? Is this true? And if the answer is yes, which in this case it is, it can equal negative 1, then all you have to do is cross them out, and the answer is negative 1. Okay? So same thing here, cosecant has to exist. So cosecant's domain that we've restricted it to is from negative pi halves to 0, or from 0 to pi halves. Okay? And is root 2 within that range? And you need to double check on this one because this one's a little bit strange. I'm going to go ahead and pull up a calculator for you guys. So the question is, does root 2 fall in this range? So let's check. The square root of 2 is about 1.4. Pi halves is 1.5. So it is within this range, but just barely. Okay, so just barely is it within this range. So these cross out, and the answer is the square root of 2. Okay, and then again, we ask ourselves, is pi fourths in the correct range for secant? And so let's check, let's see, domain of secant, normal secant here. Oh, it's cosecant. Normal secant needs to be between 0 and pi, but not pi halves. That is indeed between 0 and pi. Right? So this one is just pi fourths. Okay. So I'm just going to go ahead and put some answers down here, make sure that you understand why on these ones that I'm not going to talk about. Okay. All right, so on D and G, I put the answers. Let me know if you have questions on them. Okay, so here's the thing. Arc cosecant has to exist in order for this to happen. So we have to check, is this value between negative pi halves, or no, I'm sorry, negative infinity and negative 1, and 1 to infinity. Is that the case here? And we need to check. We need to see. So root 2 over 2, oops. Square root of 2 divided by 2 is about 0.7, which would fall right in this range. So the answer is no. This does not exist. And if this part doesn't exist, what are we even plugging into there? Nothing. There's no way to do this. So this one is undefined because it just doesn't exist at that spot. Okay. Now here's another one for you. So we need to check that 5 pi thirds is between negative pi halves and pi halves, but it can't equal 0. And the answer to this is no. This angle does not fall within that. Okay, so now we got to think through this a little bit differently. So we need to recognize that the secant of 5 pi thirds you could think about this as 1 over the cosine of 5 pi thirds if that's easier, which I think it is because now we can use our unit circle. So this would be 1 over 1/2, which of course just equals 2, right? So that's true that this part equals 2. So now what we really have is the arcsecant of 2. And then we can keep going from there. Okay, so the arcsecant of 2 is asking us, okay, what is theta if the secant equals 2? Well, then that would mean that 1 over the cosine is 2, which would mean that the cosine needs to be 1/2. But, okay, so the reason that this happened is this was all true for 5 pi thirds also. But 5 pi thirds was out of our domain restriction, so we need to figure out what it would be within our domain restriction. That's what we're doing right now. So the answer would be that theta equals pi thirds. Okay? All right, so here's another example for you. So these are the ones that you would have to draw an actual triangle on. Okay? So if we have the cotangent of the arc cosecant of square roots of 5, this part is saying that the cosecant of what angle equals the square root of 5. And cosecant, of course, is 1 over sine, which would mean that normal sine would equal 1 over that. Okay? So the reason that's important is now that when we're trying to draw our picture here, we have theta here, and our sine is now 1 over the square root of 5, which tells us square root of 5 is our hypotenuse. Okay? So if we want to find this side, it's actually 2. You guys can do the Pythagorean theorem and figure that out, but I promise it is. So now we need the cotangent of this angle, right? Because this whole big thing, that's really just an angle that you're describing. Okay? So the cotangent of theta would be equal to the cosine of theta over the sine of theta. Right? So cosine now becomes 2 over the square root of 5. And sine, we already had, was 1 over the square root of 5. And we can keep change flip this, which is nice because those cancel. The answer is 2. Okay. Now again, anytime you have inverses, that's an angle. That's asking you to find the sine of whatever that angle is. Okay. So again, let's make a little picture for ourselves. This time it's negative, which tells us we're going to be down in the 4th quadrant. So we know that the inverse cosecant is negative 3. So that would tell us that 1 over sine is negative 3. And then, therefore, sine is negative 1/3. Okay? So opposite over hypotenuse, negative 1 over 3. And then we can go ahead and figure out this side. So we know that 3 squared should equal whatever that is, squared plus negative 1 squared. So x squared needs to equal 8. So you can write x as either square roots of 8 or 2 root 2. 2 root 2 is always my preference. Okay, so now that we want the sine of that, hey, wait a second, did we even actually have to find this? The sine of the arc cosecant. Interesting, what happens here? So the sine of this is negative 1/3. Well, didn't I already know that? So I made you guys do a lot of work that you didn't actually have to do, because it already gave it to you, which is kind of a fun thing. Okay, so I will put the rest of these up on the answer key, but I don't want to talk about C right now, but you need to do it. Okay, and then with this one, I'm just going to point out that arc cosecant would result in an angle, and we know that sine of 2 theta can be rewritten as 2 times the sine of theta times the cosine of theta. Okay, and then this one, again, arc secant is going to be some angle, and arc tangent is going to be some other angle. So this is really the cosine of alpha plus beta, which you guys know is equal to the cosine of alpha times by the cosine of beta minus the sine of alpha times by the sine of beta. Okay, so it's a little bit more work because you got to get a couple more values here, but you know all of that already. Okay, so I'll give you guys the answers right here, so if you wanted to work it out, pause it, whatever, then you can, but I'll put the full results up on Canvas. Oops. -2 plus 2 root 2 over 3 root 5. And there are some other forms that this could take depending on how you simplified. But I'm going to be honest, you don't need to simplify. If all you write is this value times by this value minus this value times by this value, that's enough. That's fine. You don't need to go any further than that. You don't need to simplify it. Okay, so some more kind of weird, the really theoretical ones. Remember that this is just an angle. So this is actually asking you about the secant of theta. Well, then that's really asking you about 1 over the cosine of theta. Right? So then if we draw the picture, what this is telling you is that we have some theta and then the cosine of theta would equal 1 over x. So now our hypotenuse let me back up. I'm sorry. I'm going down a place I don't want to go. We're going to back up to this part. Okay. So arctan tells us that the tangent of what angle equals x. Well, tangent is always opposite over adjacent. So this is x, this is 1. Okay. And then for secant, we would need 1 over cosine, and cosine is our adjacent over hypotenuse. So we do need our hypotenuse in this case. So we're going to do 1 squared plus x squared needs to equal our hypotenuse squared. So this is x squared plus 1. So this is going to be the square root of x squared plus 1. And then to get our cosine or our secant, so our secant is the opposite of cosine, and cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over our adjacent. So the secant of all of that is going to be the square root of x squared plus 1 over 1. But of course that over 1 part is very unnecessary. So all we need is the square root of x squared plus 1. Okay, here's the kicker though. We have to talk about domain. What are the 2 things we can't do in domain? We can't divide by 0. And we can't take the square root of a negative. Okay, so whatever we do here, we need to make sure that we don't divide by 0. And ultimately what happens here, since there's no division in this, we can kind of skip that, but you can't take the square root of a negative. So x squared plus 1 has to be greater than 0. Therefore, x squared has to be greater than negative 1. Well, this is always true. X squared is always, always, always positive. So this is not even, like, this doesn't really restrict it because that would always be true no matter what. So our domain here is all real numbers. There is no way to make this untrue. Okay, there's another one here for you that does have a domain restriction on this one. So I will tell you what the answer is, but if you want more details, you're going to have to check the notes. You guys should be able to do this on your own. Okay, so this is the answer, and then the domain gets restricted from -1 to 1. And you guys can check the completed notes for more information on that.